All right, guys, let's take a look at section 10.4 dealing with misleading graphs and statistics. Misleading graphs and statistics, they can be found all over the place. You guys have probably watched advertisements on TVs, commercials, anything on the radio. A lot of times can be misleading in terms of telling you one thing when it actually means another. So our learning target for today is to be able to identify what makes graphs misleading. And we'll take a look at those characteristics throughout this lesson. So if we see our graphs can be used to influence what people believe, the way data is displayed can often influence how the data is interpreted. Right down below here we have a video, so go ahead and watch this video. It's about 4 minutes long, and it's just a couple advertisements and see if you can find the misleading data in it. All right, now that you took a look at that video, hopefully you found some things in that can make that misleading, and let's take a look now at some graphs from scenarios in our textbook that can be misleading, from bar graphs to line graphs to circle graphs. First of all, let's take a look at this. This talks about customer satisfaction. You can see on the y-axis here, the customer satisfaction percent. Here's a big thing that can make graphs misleading. We often encourage you to use these right here, but they definitely can be misleading. So this break right here is one thing that makes this misleading because it appears as if graph B is way, way higher than graph A, when in fact, if you take a look at graph A, it looks like it's right around 79, and graph B actually is at 86. So is brand B definitely better? Yes, it is according to the graph, but it makes it look like it is almost twice as big. Same thing with graph C and with graph D. Believe it or not, 83% compared to 86%, only really a 3% difference between the two. So this graph is misleading because of the break on the y-axis. And sometimes you'll find other things that make it misleading. We'll look at a pie chart here in a few minutes. What might people believe because of this graph? Well, when I look at this, I think I definitely want to go out and use brand B because, like I said, it appears that it's almost twice as good when in fact, it's really only about 7% is the maximum difference between brand A and brand B, and brand C and brand D are even closer than that. So what might people believe because of this graph? That brand B is by far the best brand. So you got to be careful whenever you use breaks. Like I said, we have taught you to use these throughout the year, but it definitely can result in misleading graphs. And then who might want to use this graph? I think we could definitely agree that brand B, whether it's Nike, whether it's Reebok, whether it's Domino's Pizza, whatever it is, it's going to use that to show that they are significantly higher than any other. Now let's take a look at another one. Here's an example of a pie chart. This is talking about the county budget for 2005. So once again, let's take a look at part A. It says, or step A, I'm sorry, it says, why is the graph misleading? Well, if you take a look here, and this is something common that pie charts do, most pie charts add up to 100%. You've probably done pie charts in the past. However, you notice this one, 20%, 25%, 10%, 5%. This actually adds up to 60%. So you can tell that this is not going to be an accurate representation of an entire pie. So whenever you see that, that's definitely going to be one reason why a pie chart is misleading. The pies do not add up to 100%, and that will definitely skew your data distribution. Part B says, now let me just double check what those represent. What might people believe because of this graph? Excuse me. People might believe because of this graph, well, that the county budget is essentially half of it, it appears, is based on road maintenance. And when in fact, only 25% is the road maintenance. So it appears that it's about double whatever it actually is. So somebody might believe that road maintenance has too much money allotted to them, maybe allotted to their department, when in fact, like we said, it's only about 25%. Still a big chunk, but nothing compared to what this pie makes it seem. And then part C, somebody who who would want to use this graph, maybe somebody who is against spending money, a person who is advocating for more money on maybe social services, or maybe parks and recreation, or garbage collection even, versus road maintenance. So a person who is advocating for more money for the other categories. So once again, it's a way to show that your category that you're advocating for is not nearly as represented as the other categories are. So here's an example of a pie chart where you can have misleading data. Once again, that's the main time you see that is whenever you are given pies that add up to something other than 100%. Definitely throws off your data. Now, let's take a look at this question here. Statistics can be misleading because of the way the data is collected or the way the results are reported. This is actually an extension in the textbook at the end of section 10.4 if you wanted to check it out. There are a few good activities in there. A blank is a good way to collect unbiased data. All members of the group being surveyed have an equal chance of being selected. This is what we call a random sample or random survey. Random survey is the best way to get your point across because it has unbiased data. Unbiased, you probably are familiar with that term. Unbiased simply means that everyone is given a fair chance and there is no favoritism, essentially, as to who you're going to pick, which one is better, which one is worse, and so on. Let's take a look at this question down here. A study of 5 households found the number of pets per household, 2, 1, 1, 9, and 1. Explain why the following statement is misleading. The average household has 3 pets. Take a few seconds, think about it. So if you look here, there's an outlier, and no, a household actually has 3 pets. So that 9 there really throws off your data. This is another popular way to make data misleading, is by throwing an outlier in there. Better way to do it would maybe be the median, which we will talk about, or which we already did talk about back in section 10.3. Let's take a look at the next question. Go ahead and read it. Pause your video. A researcher asked 5 people if they like to snow ski. 4 people respond yes. Explain why the following statement is misleading. 80% of people like to snow ski. Go ahead and pause that and jot down what you think. And then if you see here, it is way too small of a sample size. You can't go out and survey 5 people and then assume that you have an accurate representation of what your question is. So you definitely need a much bigger sample size. Now, can you think of any real-world examples in which you encountered or saw a misleading graph? Pick up a newspaper, turn on your TV, turn on the radio. You'll probably hear, you'll see, you will read different examples of where data is misleading. One example, the best way to show that is, like we said, through a graph. And we talked about some ways to make them misleading. Not starting your graph at 0, making your intervals maybe a little smaller or a little bigger than they actually are, making them uneven intervals, and so on. Well, that reminds me, I'm sorry, let me go back here quickly. I forgot to mention, I'm sorry, never mind. Cancel that, we did cover all of that. All right, let's take a look at this question. If I went up to 7 Springs and interviewed people on the ski slopes by asking them if they like to watch the Winter Olympics, what would be misleading about concluding that 90% of people like to watch Winter Olympics? Well, think about that. Go ahead and pause this and write down a couple ideas that would make this misleading. All right, so in this case, in my opinion, going up to 7 Springs and saying, hey, do you like to ski? Do you like to watch the Winter Olympics? Well, obviously, you're on a ski slope. 90% of people, I'd imagine they like to be skiing. They probably like to watch the Winter Olympics. It's like going into the mall, going into Nordstrom's and say, hey, do you like to shop? Sure. I mean, if you're at Nordstrom's, you probably enjoy shopping. So that's an example of something that makes it misleading as well. Read and study example 4. That's basically the same type of problem as what we just looked at in the textbook. Check it out, number 4, and think about how you would respond to that. So go ahead and pause this and take a look at that question. Here's another example of Pirates pitching salaries. So back in 2008, there were these 5 starting pitchers on the team: Snell, Maholm, Duke, Gorzolani, and Morris. Morris makes a ton of money in comparison to these 4. So once again, we have an outlier that is totally throwing off our average. Our average comes out to $2.3 million approximately, when in fact only one is way above that and the other ones are nowhere near it. They are below it. So an outlier is an excellent way to throw off your data, and mean averages is definitely not a good method to use. And then quickly, the section 10.4 closer. Discuss the following types of sampling and tell whether or not each one could be considered biased. So simple random is about as good as it gets. Every person has an equal chance of being chosen. Stratified random, the population is divided into similar groups, then a simple random sample is chosen. And systematic random, a sample is chosen at a regular interval. Now, any sample technically could be biased, but these are examples. Anytime you see something that is random, usually that is going to be a good representation of a non-biased survey. In this case, stratified population is divided into similar groups, then a simple random is chosen. You could divide them into groups of your friends. That could be an example of something that could make it biased, because if I go to the lunch table and I choose every other person from the lunch table, most likely kids that are sitting at that lunch table maybe have the same likes, same things they enjoy doing, hobbies, sports, listening to music, whatever it might be. And then systematic random, a sample is chosen at a regular interval. That's like what I said with taking every other one. So hopefully you have a better idea on section 10.4 as to what makes graphs misleading. And data we have from graphs not starting on the x-axis or y-axis at 0. We also have intervals that are uneven. We have pie charts that do not add up to 100%. And once again, there are other things that you could find, but those are definitely the main ones.